So we've looked at how to find the derivative of power functions and different combinations therein of power functions. But there are more than just power functions out there. And the two that we're going to focus on right now are inverses of each other. They're e to the x and the natural log of x. And the derivatives of these are not really what you would expect, maybe. So if f of x is e to the x, then, get ready for this, the derivative of that is e to the x. E to the x is an invariant function. Its derivative is itself. And at a higher, deeper level, we can prove this and show this. We're not going to focus on that in this course. F of x equals natural log of x. The derivative of that is not itself. The derivative of that is 1 over x. So these are derivative rules that you need to know. And even that is kind of a loose thing to say because they're in your IB formula book. These rules for derivatives of e to the x, natural log x, they are provided to you in your formula book. So let us do some examples. Or an example, I suppose. So we want the derivative of this. This is a whole combination of a bunch of stuff. So let's go through this. First thing to notice is that we can simplify here. That thing could be simplified. So let's go ahead and do that before we differentiate. Our f of x is equal to 3 e to the x. What happens when you take the natural log of e to some power? Thinking back to our log study, that exponent come down, natural log of e is 1, so this is just 3x. And now that we've simplified, let's take the derivative. What's the derivative of e to the x? Well, it's e to the x. So the derivative of the first term is 3e to the x. Plus, derivative of the second term is 3, plus 2x, plus 1 over x. And there we go. There's our derivative. That's all it is. We're just going to be using these two new rules in the context that we've seen in all of these other things with product rule, quotient rule, in a combination with some power functions. And as we get more complicated, we'll continue to use these rules for derivative of e to the x and natural log x. And that, ladies and gentlemen, is where I shall leave you for today.